Welcome to Avian Institute of Engineering and Technology. I am myself Khaja Misbauddin Khadri, Assistant Professor in Physics. Today I would like to explain optical fibers and their applications. As per the curriculum of JNTU, for electrical as well as non-electrical branches, optical fiber is introduced in the fifth unit. Now let us have some of the points or topics in optical fibers. The name optical means it is light. Fiber generally plastic, combination of plastic and glass. So optical fiber is a cable which is used for the transmission of light by using the principle of total internal reflection. First of all, we should know what an optical fiber consists of. It is called construction of a fiber. An optical fiber is the combination of plastic dash plastic, 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 glass, plastic, glass. So there are so many combinations. In this, plastic, glass are generally preferred. An optical fiber is having two parts. The two parts of the optical fiber, one is core, is having refractive index and 1. Another one is cladding, is having refractive index and 2. Core is a denser medium, cladding is a rarer medium. Generally, for the propagation of light, N1 must be greater than N2. N1 must be greater than N2. Let us see a figure which can clearly depicts optical fiber cable. If you take an optical fiber cable, it has a cable may have so many optical fibers. Let us study about the inner structure of the optical fiber. This optical fiber cable has many optical fibers. One fiber, if you take the enlarged view, consists of, this is cladding, its refractive index and 2, and this is core, its refractive index and 1. So this is the construction of an optical fiber. Generally, light propagates through core only. The dimension of core cladding are very small. Generally, the dimension of core is around 50 to 100 micrometers. The dimension of cladding is 100 to 250 micrometers. So this is about the construction of an optical fiber. Now we will go to the next topic under optical fiber, that is principle of optical fiber. Here a question arises, how the optical fiber transmit the light. Optical fiber transmit the light using the principle total internal reflection. So principle of optical fiber. Let us take two medium, denser medium and rarer medium. Suppose here is a combination of core and cladding. The upper medium is, let us suppose, is core, having refractive index n1. The lower medium is, suppose, cladding, having refractive index n2. This is the interface. This is the interface between the two media. That is, this is a denser medium. This is the denser medium. The another one, the bottom one, is the rarer medium. Let us have a normal in these two. Normal means a line perpendicular to the interface. Let us suppose that a ray is passing from denser medium to rarer medium. A question arises, how the ray pass? As you know from Snell's law, if a ray passing from denser medium to rarer medium, it bends towards the normal. It bends towards the normal. So accordingly, if you take that, yes, if the ray passing from denser medium to rarer medium, it pass away to the normal, that is, accordingly the ray will be taking this direction. But if this angle of incidence, if you increase, then what happens? A particular angle called n1 sine theta 1 is equal to n2 sine theta 2. What is theta 1 here? Theta 1 is angle of incidence. Theta 2, angle of refraction. Okay. If this angle becomes 90, suppose if theta 2 is equal to 90, then the equation is, yes, sine is n1 sine theta 1 is equal to n2 sine 90. As you know, sine 90 is equal to 1. So then the equation according to this, if the ray is passing from middle, then this is the equation. n1 sine theta 1 is equal to n2 sine 90. As you know, sine 90 is 1. So the equation is n1 sine theta 1 is equal to n2. Therefore, sine theta 1 can be taken from this equation. So, you can take the equation and sine theta 1 is equal to n2 by n1. Theta 1 is equal to sine inverse n2 by n1. If this a ray passing through a rarer denser medium with this angle, then the refracted ray will pass through the interface. So theta 1 is this much, then theta 2 already we have taken 90. So based on these two values, we can design the optical fiber. How it is? Let us take this equation in application. By using this equation, we now plan for three different situations. One is refraction, another one is grazing, and third one is total internal reflection, which is needed for the optical fiber guiding. For the guiding of optical fiber, we need total internal reflection. Let us take three cases. Let us have case 1, the same diagram which I have explained. Once again we take in three cases. So case 1, it consists of angle of incidence less than, yes, which is we calculated. Theta 1 is sine inverse n2 by n1. This is called critical angle. Instead of naming theta 1, we name it as now critical angle. When theta incidence is critical angle, then theta refraction is, yes, is 90 degrees. So keeping in view theta 1 if it is less than critical angle. Another case, if theta 1 is greater than or equal to critical angle. The third case, if theta 1 is greater than critical angle. Let us take that case. If theta 1 greater than critical angle. So all this here we are dealing with incident ray. Incident ray with a normal, how much angle it makes. If it is normal, this angle of incidence, how much angle this will make? This is less, more and more. So let us have this. See, this is the interface. This, let us suppose, denser medium. This as rarer medium. How? We are just assuming that n1 is greater than n2. For all the figures, interface, n1 greater than n2, n1 greater than n2. All are having denser medium, rarer medium. Now let us draw a normal. Here is another normal. Here is another normal. Let us suppose a ray is coming with an angle less than critical angle. Like this is the ray, it is making the angle critical angle. So I already told this is a denser medium. So ray goes away from the normal. This is the diagram. Whereas if this angle you are increasing equal to critical angle, then the ray passes through the interface. See, you are increasing this angle. You are increasing this angle. Suppose if I increase this angle more, that is, this is the angle of incidence. See here, compare this is very less than critical angle, equal to critical angle, greater than critical angle, then the ray comes into the same medium. This is called, first of all name this. This is called refraction because ray is going into from one medium to another medium. This is called ray is passing through interface. This is called grazing. Ray is passing through interface, grazing. Whereas this one, ray goes totally into the another medium. This is called total internal reflection. This is the actual principle of optical fiber. So the principle means on what basis ray go on passing in core is total internal reflection. We can take this into more clear. That is, let us have an optical fiber cable. This is a cable. This consists of outer cover and also cladding and also core. We are just assuming that light is only passing through core, because as cladding, you know, it's rarer medium. See, this is the cable axis. This is a cable axis. You are giving the light to the optical fiber here. If this angle is greater than theta, incidence is greater than, suppose if this is acceptance angle, well, I will explain later what is this. But now you keep in mind if it is more than acceptance angle, or you can have another case less than acceptance angle, third case equal to acceptance angle. These are related to this inner what we have discussed just now, but we are in the safe zone. We think that light propagates, so theta I should be less than acceptance angle. How you should make acceptance angle? You should make one angle based on this. You have to cover it, you have to make a cone. So now it is clear that you have to feed the light through this cone only. When we are giving light to the cone, the light undergoes PIR. So it passes through in different directions through core only. So this is the principle. Here you see interface, here you see another interface, here you see one more interface. So they are all completely sending the light into the core only. This is called total internal reflection. Now I explain two concepts. One is introduction, that is optical fiber. It consists of core and cladding. Refractive index of core is N1. Refractive index of cladding is N2, as N1 is greater than N2. The another concept is total internal reflection. Now we will go for the applications part of an optical fiber, because nowadays most of the people in the real world, technology is gone improving or updating itself. In this fast generation, now you see 4G has come, 5G is going to develop now. In this advanced generation, if optical fibers properly applied, then the technology can more and more enhanced and the rate of transfer of data can be decreased. See how the optical fiber is having applications. Generally, optical fiber is a cable which can transmit light, but if you mix electricity in light, you can send the light electricity in terms of light. That is called optical fiber communication. Optical fiber communication. These are many advantages over copper cables. It has many advantages over copper cables. The second application is optical fibers are used in medicine. Previously, there was a surgery which requires many equipments, as well as there were many difficulties. But once optical fiber came, they are using in laparoscopy. They are using laparoscopy. Also endoscopy. So this consists of an optical fiber added device. Is a device, medical device. It consists of two fibers. One is carrying light, another is carrying the image of the inner part of the human body. The third one is optical fibers are used as sensors. they sense temperature. So optical fibers are used for temperature sensing. Also they are used pressure sensing. Also displacement sense. So these are the few of the applications of optical fiber. Okay, thank you very much for giving the opportunity.